All right, Unit 3, Topic 2, matrices and vectors, position vectors as a function of time. And we're looking at two particles, particle A and particle B, and we're given their position as a function of time, and we're looking at when they collide. So this is one of those collision questions. So they collide if the two particles are in same position at same time. So we're looking at when RA equals RB. So we want them at the same position at the same time. Now this is not an easy one. I purposely have done one that's a little bit trickier. It's out from the textbook, it's from your exercise. So it's a little bit different. So if we're looking at when RA equals RB, we're equating that the I's will be the same and the J's will be the same. So I'm going to equate. So I's will be the same, will be 6t squared equals 13t take 6. And the J's are 2t cubed minus 18t equals 3t squared minus 27. That's a bit of a yucky one to solve because that's a cubic. But remember, if this is tech active, you can just use solving a polynomial on your graphic calculator. This one's not so bad. We're going to have 6t squared minus 13t plus 6 equals 0. Still, I'm going to go to my calculator to solve this. I'm going to go to my menu and I'm going to go down to equation. I'm going to go polynomial, degree 2, 6, oops, I left out my negative, negative 13, 6, solve, and I get two equations, or two values. T is 1.5 or T is 2/3. So I do need to confer with my other equation. Now my other equation is 2t cubed minus 3t squared minus 18t plus 27 equals 0. So I'm going to just pop that into, go back here, degree 3. So I'm 2, negative 3, negative 18, 27, solve. And when I solve there, I get 3, 1.5, or negative 3. Oops. Of course, that's not it because t should be bigger than or equal to 0 because t is a time. So we look here and we go, okay, what's in common? The 1.5. So they collide when t equals 1.5 seconds. That's my when. What about my where? My where would be just put 1.5 into one of your equations. Just picking the first one, RA, so that's 6, 1.5 squared I plus 2, 1.5 cubed minus 18 by 1.5 J. Pop that into my calculator. I need to go menu, back up to my regular, oops, run mat. So 6 times 1.5 squared equals 13.5 I. 2 times 1.5 cubed. Take away 18 times 1.5. Negative 20.25 J. If you were asked to justify that is a reasonable where, so you justify by just doing RB. And we just sub it in the same as we did before. And we pop that in and we can just justify it as 13 times 1.5, take 6. Yep, that gives me 13.5 I plus 3 times 1.5 squared, take 27, negative 20.25j. So we've justified our answer. So just reminding, if we're given the position vector as a function of time, if in a collision question we're looking at that the particles are in the same position at the same time. So we just equate out the i's and the j's to find out time. You could be asked other things as position vector as a function of time, such as where was the initial position, in which case you substitute in t equals 0, or you may be asked, what's the position at t equals 10, say, and you can work it out. All right, that's it, I'm done.